Well, welcome to chapter 13. So we're going to be starting our one of our two big units today, and this is reduction and oxidation chemistry, or redox for short. Probably the most important thing about this unit is getting the vocabulary down really early. We're going to have some sayings like ogre and ralio and oil rig, and we have to be able to use those to explain the transfer of electrons in chemical reactions. So we just finished enthalpy, and we were looking at the transfer of energy with endothermic and exothermic reactions. Now we're looking at the transfer of electrons with reduction and oxidation reactions. So some of the patterns are the same. It's just a different vocabulary, and now it's electrons instead of energy. So I thought I'd start off today with a song, and you have to try and figure out what the heck this song has to do with chapter 13. So here we go. Okay, hopefully you caught that. I'll let you figure that out, what the heck that had to do with this unit. The song was by Megadeth, in case you're wondering. All right, so here we go. Let's dig into it. Oxidation and reduction. Okay, give me my eraser. All right, so in this chapter, you are going to be able to look at a chemical reaction like this and be able to recognize that iron is going to iron 2 plus. How did it get to 2 plus? Well, it lost 2 electrons. And when you lose electrons, that's called oxidation. Copper is a charge of 2 plus, and it went to copper neutral, or an element with a charge of 0. How do you get from 2 plus to 0? You have to gain electrons, and when you gain electrons, that's reduction. So this is the kind of skill that you're going to learn in today's class. Looking at models of atoms, we can see that this atom is losing its electrons, and this one is gaining the electron. So this is a transfer. If you lose electrons, it's oxidation, and if you gain, it's reduction. And we use the term oil rig to help us. Oil, oxidation, is a loss of electrons. Rig, reduction, is a gain of electrons. So we'll use those over and over. Here's another way to look at it. So we have a compound here. It is a reducing agent. And the saying that we use is ralio, reducing agents lose electrons to become oxidized. So what happened to this reducing agent? It went into the reaction, and when it came out, it had 2 less electrons. If you lose 2 negative electrons, you would actually become 2 positive if you started off as neutral, A0. At the same time, and remember in our last chapter, we learned to have a chemical reaction, you need a collision. So B is colliding with A, and we're going to say that B is also neutral. It's just an element starting off with 0. B collides with A, and it gains 2 electrons, so it has become reduced. We say that oxidizing agents gain electrons and become reduced. So B0 gained 2 electrons and become B2 minus. If we wrote that out as reactions, we would say that A reacts with B to produce A2 plus and B2 minus, and that's what we would call a redox reaction. And you would be able to break it apart and go, oh, okay, A lost 2 electrons and B gained 2 electrons. So those are the skills you're going to learn in today's lesson. Tomorrow, just to give you a little preview, I am going to be giving you my own version of a reduction oxidation song, which I call Lose, Lose, Lose by the Reducing Agents. So I have a copyright on these lyrics, but you're more than welcome to take them and use them, and I'll be sharing that with you at the start of tomorrow's lesson. Something to get really excited about. All right, here we go. Modern redox theory. So in your study guide, you will want to pause this and copy these down. These are critical to your success in this chapter, is being able to use the vocabulary and understanding the key ideas. So please write these down on page 190 of your study guide. And here's the last two, so you can pause again to fill in 5 and 6. Okay, so what do these mean? What's going on? In order to be a redox reaction, there has to be a transfer of electrons. It's kind of like an enthalpy. In order to have a change in enthalpy, you need a transfer of energy. Somebody's losing, somebody's gaining. In every redox reaction, we have both an oxidizing agent and a reducing agent. And you'll learn how to identify those. Those are the actual chemicals gaining and losing the electrons. So we use the term Auger. An oxidizing agent gains electrons to become reduced. And the example would be, here's a copper 2 plus gaining 2 electrons to become copper. Now, some students struggle with the idea of recognizing that copper 2 plus is gaining here. I want you to think of electrons like energy. If we had energy here, so instead of 2 electrons, let's say I wrote copper 2 plus 50 kilojoules becomes copper. And I said, is this reaction endo or exothermic when energy is on the reactant side? You would all say that it is endothermic. And you know that endothermic is a gain in energy. So now replace kilojoules with electrons. So when they're on the reactant side, we say they're gaining the electrons. Okay, so keep that in mind. And then the same thing for a loss. If we had energy, exothermic, we would put energy on the product side and we would say the reaction is losing energy. When electrons are on the product side, we say that the reactant has lost electrons. So it would be a reducing agent. Reducing agents lose electrons and become oxidized. Ralio. The other terms you'll see are Leo. The lion says gur, and Leo is when you lose electrons, you're oxidized, or you lose electrons, oxidation, gain electrons, reduced, or gain electrons, reduction. Reduced and reduction mean the same thing, and oxidized, oxidation mean the same thing. And then finally, in any redox reaction, the electrons gained have to equal the electrons lost. In other words, they balance. So we're going to learn how to balance redox reactions in this chapter. Dead without them. You got to know these 6 key concepts. Okay. So now we're going to take a look in detail at a half reaction, and we're just following along in your notes on page 190. So a half reaction is defined as a reaction that shows the electrons either being gained or lost. So it usually is it is one chemical and its electrons gained or lost. So in this case, it's copper 2 plus. And you can see here that the electrons are on the reactant side, so it's gaining. Okay, so if it's gaining, then we're interested in the saying that has a G in it, rig, or the G in it, Auger, for gain. Both of these mean the half reaction that gains. So once we recognize that the electrons are on the reactant side and they're being gained, we can go, okay, rig, gained, it's reduction. Reduction is a gain. And we can talk about the copper 2 plus. Is it an oxidizing agent or a reducing agent? Is it getting reduced or oxidized? So again, it's a G for gain, so this is the one we're after. Copper 2 plus is an oxidizing agent. It's gaining electrons and becoming reduced. So once we recognize the gain, we can classify the reaction as reduction, and we can say that the copper 2 plus is gaining electrons to become reduced. Is this a redox reaction? Is there a transfer of electrons? Yes, but it's only half of the reaction. Okay, here's another one. Gold 3 plus, 3 electrons being gained on the reactant side. So as soon as we recognize its gain, we know we're dealing with Rig and Ogre. Is it reduction or oxidation? Rig, it's reduction. Is Au3 plus the oxidizing agent or reducing agent? OA, it's the oxidizing agent, gaining electrons. Is this a redox? Is there a transfer of electrons? Yes. And again, it's a half reaction. Okay, number 3, excuse me, S2 minus, going to sulfur as an element, and 2 electrons, and this time they're on the product side. What does that mean? A gain or a loss? Just like energy on the product side, it's a loss. So now we're looking at the mnemonics or the summaries that have an L in them. Oil, Ralio. So there's our answers. Oxidation is a loss. Is S2 minus the oxidizing agent or reducing agent? It's the reducing agent that loses electrons. Is this a redox reaction? You bet. Again, it's a half of the reaction. Okay, last one. 2 chlorides become chlorine and lose 2 electrons. So oil and Ralio are the 2 sayings that have lose in them. So you can answer these questions. Is it reduction or oxidation? Cl minus getting oxidized or reduced. Is this a redox reaction? Yep. Okay. So that's skill number 1. Given a half reaction, be able to explain oxidation, reduction, oxidizing agent, reducing agent. Now you have to be able to build your own half reactions. So we're going to take a look at this balanced chemical equation and identify the 2 half reactions. So the rule is you take ionic compounds and you separate them into their ions. So 2MgO is like having 2Mg2 plus and 2O2 minus. If I break that apart, if I'm not balancing it, I could also just write it as Mg2 plus and O2 minus. Okay, so now half reaction number 1, Mg goes to Mg2 plus. Half reaction number 2, O2 goes to O2 minus. So that in a half reaction, you have to keep the same chemical, magnesium and magnesium ion, oxygen and oxide ion. You couldn't write Mg turns into O2 minus. Of course, that wouldn't make sense. All right, now we have to figure out electrons and balance. So I'm going to balance my atoms first, just because it's bothering me that they're not. I have O2, now I have 2O. And if I want, I'm just going to leave it like that for now. Okay. Maybe I'm not. I'm going to throw those in as well and balance it. Okay, the last part is critical. Now we need to add the electrons. Who's gaining, who's losing? It's a very simple way to figure this out. And it is the following. Add electrons to the more positive side. This is where students always struggle. Do we put the electrons on the left or the right? How do I know? So elements have a charge of 0. So if we look at magnesium, we've got 0 on this side and plus 2 on this side. So that means we're adding them to the more positive side. How many are we adding? Well, we actually have 2 atoms of magnesium. For a total, it's still 0. And over here, I've got 2 Mg2 pluses for a total of 4 plus, 4 minus. Okay, second reaction, this side is 0. This side is 2 times 2 minus is 4 minus. So I've got 0 and 4 minus. 0 is more positive. How do I balance them out? I need 4 minuses to add up to this 4 minus. Okay, if I want to write my overall reaction, I'm going to add them together now. 2Mg react with O2 to produce 2Mg2 plus and 2O2 minus. I'm going to ignore states just for, well, I could put them in simplicity. Everything in here, that's a gas. This is a solid from the ion. Now, what about those electrons? I didn't add those in. We have 4 being gained and 4 being lost. So like net reactions in enthalpy, when you have something that's the same on both sides, they cancel out. So those electrons are being transferred, but we don't need to show it in the overall reaction because it's 4 gained, 4 lost. So they balance out. Now that we've done this, you should be able to, oh, and by the way, if you wanted, you could combine these. That's up to you. 2MgO solid, or leave them as the separate ions. Both are correct. So now we can answer all these questions. Which reaction is reduction? Okay, reduction. So reduction is Rig, gain. Which one is gaining electrons? We're looking at the half reaction. This one is half reaction number 2 is gaining 4 electrons. Oxidation is a loss, oil. And we have reaction number 1 losing 4 electrons. Who is the reducing agent? Reducing agents lose electrons. Ralliot. Who is losing electrons? Magnesium is losing 4 electrons to the product side. So half reaction number 1. Who is getting reduced? Oxidizing agents gain electrons and get reduced. Who's our oxidizing agent gaining electrons? Oxygen is. O2. Oh, I forgot to put who is the reducing agent. I just put reaction number 1, Mg. Who is our oxidizing agent? Okay, oxidizing agents gain electrons and become reduced. So oxygen is our oxidizing agent gaining electrons. Who is getting oxidized? Reducing agents lose electrons and get oxidized. Magnesium. Okay, so you can see how critical it is to understand and use these little sayings to identify and explain. Reduction and oxidation are both reactions, and you can use oil rig to determine that. Reducing agent and oxidizing agent are chemicals or chemical species, and we can use Ralliot and Auger to figure that out. This is really a key idea, understanding the difference between reduction and oxidation and reducing agents and oxidizing agents. So, as we just stated, reduction and oxidation are both processes involving reactions, and reducing agent and oxidizing agent are the individual chemical agents or species. All right, how are you guys doing? You need to pause and take a break and digest that information. We're going to practice it with a few more half reactions and net reactions. All right, so given this reaction, write out the 2 balanced half reactions. So what have we got here? Zinc, and over here this is an ionic compound. Well, and this is an ionic compound, so I'll just separate them up above. That's made of gold 3 plus and NO3 1 minus. This one's made of zinc 2 plus and NO3 1 minus. Okay, zinc goes to zinc 2 plus. Au3 plus goes to Au. And NO3 1 minus goes to NO3 1 minus. All right, so now we have to figure out who's gaining, who's losing. And as it says here, any chemical that does not change from the reactant to the product side is a spectator. So which of these 3 reactions contains the spectator? There it is. So we can ignore the NO3 minus. It's actually not part of this reaction. It's just a spectator ion floating around. All right, zinc goes to zinc 2 plus. So who gets the electrons, zinc or zinc 2 plus? Remember the rule, whoever's more positive, zinc as an element is 0, and here it is as 2 plus, 2 minus. Gold is 3 plus, here it's a 0. This is the more positive side, it gets 3 electrons. Okay, 2 balanced half reactions. Okay, so we're done there. There's our half reactions. And if we wanted to apply anything, this is a loss of electrons. So this is our Rayleigh. This is our gain. So we would put Auger. And now I could answer all kinds of questions. We could say zinc is the reducing agent. It is losing electrons to become oxidized, and this half reaction is oxidation. Over here we have gold 3 plus as our oxidizing agent, gaining electrons and undergoing reduction or getting reduced. So now we can talk about the half reactions. Okay, and in this example, they're telling us Fe solid undergoes oxidation. Oxidation is a loss, so it is losing, and we can see it goes from 0 to 2, so it's losing 2 electrons. So I could write out its half reaction. Fe goes to Fe2 plus. Which side do I put the electrons on? It's losing. Okay, and copper 2 plus goes to copper, and it tells us it's reduction. Reduction is a gain. Which side do we put the electrons on if it's gaining? So there's our 2 half reactions, and that is a redox reaction with a loss and a gain. Okay, how can you tell if you are dealing with redox reactions? Look for the electrons being transferred. Okay, so is this a redox reaction? Because not every chemical reaction is. Is there a gain and a loss of electrons in this one? Let's figure it out. Mg goes to Mg2 plus. This is an ionic compound made up of Fe3 plus and O2 minus, and this one's made up of Mg2 plus and O2 minus. Okay, so Mg goes to Mg2 plus. Fe3 plus goes to Fe. I'm just skipping states for now to keep it simple, and O2 minus goes to O2 minus. Okay, so here's our spectator. The oxide doesn't actually change. Magnesium goes to Mg2 plus, gains 2 electrons, and Fe3 plus goes to Fe0, so we add our electrons to the more positive side. And there we go. Now, coming up, you're going to be able to balance these things. And when you're balancing them, it's actually pretty easy. We just have to have the electrons gained equal electrons lost. And right now you can see they don't. We have 3 gained, 2 lost. So we need to go with the common multiple of 3 and 2, which is 6. So we would multiply everything here by 3 to give us 6 electrons. And we would multiply everything here by 2 to give us 6. So 2 of those becomes 6 of those and 2 of those. Now the electrons gained equal the electrons lost, and this would be our balanced redox reaction. Boom, and you would be able to tell me who is the oxidizing agent and the reducing agent. So this is a loss. Here's our reducing agent, losing electrons. This one is gaining, so this is our oxidizing agent gaining electrons and undergoing reduction. I use these sayings the entire unit. They are so very important to you. Okay, so one left to do. This time we're going to look at one in picture form. So you've got Ag plus ions and copper solid as our reactant, our reactants. So I'm just going to write those out. Ag plus and copper as the reactants. And down here in our products, we are getting copper 2 plus and Ag solid. So copper becomes copper 2 plus. Let's clean that up. And Ag becomes Ag solid. So now we need to balance the half reactions. Add those electrons. Which side and how many? +1 and 0. Add to the more negatives. So now we have +1, -1. It's balanced with a charge of 0 and a charge of 0. Okay, copper is an element, charge of 0, 2 plus. Add the electrons to the more positive side, 2 plus, 2 minus. Now we have a charge of 0 and a charge of 0. So these are the balanced half reactions. If I want the net reaction, I have to balance electrons. So my common multiple is 2. 1 electron, 2 electrons. So this top reaction gets times by 2. 2 of those, 2 of those, 2 of those. And now my electrons balance. 2 gained, 2 lost. So they cancel out, and we can add everything up. 2Ag plus react with 1 copper to make 2Ag and 1 copper 2 plus. And I'm just going to leave states out for now. And now we need to answer some questions. Before we answer these, let's write out our mnemonic. So this one is gaining. So there's our oxidizing agent gaining electrons reduction. This is a loss. So there's our reducing agent losing electrons oxidation. And again, it's all about who's gaining and who's losing. So now you can answer all 6 of those questions using these sayings. And when you have that done, this is your assignment. And I'm just going to scroll down to give you the textbook page and the answers. So you can work on this, and then you can check back. You can pause the lesson and then check to see how you did. So here are the questions, 7, 8, 9, 10, and 11 in your textbook. And then here are the answers. Okay. So you could pause on that screen later on after you have tried these questions. And that's it, okay? Hope you guys have an awesome day. Be safe out there. Keep practicing the social protocols of staying 6 feet away from everybody except those in your house. And hopefully we'll flatten this curve and get ahead of this thing rather than stay behind and chasing it, okay? Take care, everybody, and I'll talk to you tomorrow.